Welcome to Train Signal. You are watching Virtualization for Disaster Recovery. In this lesson, we'll cover the following topics: why virtualization enables a superior disaster recovery, or DR, what DR was like before VMware, how VMware simplifies DR for your business, how Site Recovery Manager, or SRM, automates and enhances DR in your VMware environment. And we'll overview the SRM architecture at a high level and introduce you to the major components. And with that short introduction, let's dive right into the rest of the lesson. Virtualization enables a superior disaster recovery capability. Well, why is that? Although in many ways a virtualized machine looks, tastes, and sounds just like a traditional machine, there are some very unique characteristics that are intrinsic to virtual machines that provide DR advantages over their less capable physical server brothers. Those key characteristics are summed up in the following couple points: compatibility, isolation, encapsulation, and hardware independence. First off is compatibility. Compatibility basically says that a virtual machine is capable of running on any standard x86 computer, whether it's Dell, IBM, HP, or any type of white box computer. This is because VMware ESX software that hosts the VMs, it abstracts the physical server resources and presents a standard x86 virtual computing environment that the operating system sees as a standard x86 computer. The second key characteristic is that of isolation. Virtual machines can't affect other VMs' operation. What this is saying is that even though many different virtual machines can be running on the same computer system, the execution of the different applications and operating systems do not affect each other. Each VM behaves as if it was its own physical server with a single OS on it. That also means that each VM will securely operate in its own virtual container, even if other virtual machines were to maybe become infected by a virus or compromised by a hacker. The third characteristic is that of encapsulation. This is an important characteristic in that a virtual machine really is just a set of discrete files on a file system. The entire computing environment of a server, its data, its applications, its operating system, and the virtual hardware description that makes it up, which would describe the memory or the number of CPUs that the VM has, all of that stuff is contained within these files, or it's encapsulated. Since all those components are encapsulated in files, we know what we can do with files, right? We're very versed as IT people in copying files, versioning files, and moving them, which leads us to another characteristic that's most critical to what we're talking about in this video, which is disaster recovery. And that is a characteristic called hardware independence. This means that a VM is independent of the hardware that it's running on. A VM does not care what physical server it's running on, just as long as it has the supported version of VMware ESX running underneath it. That is what enables you to run on the latest and greatest servers in your primary data center, and possibly use a slightly older version of server hardware or the older servers that you replaced, and put those servers at the disaster recovery site. They're not identical by any means, but since the software emulates a virtual hardware on top of that, we can take virtual machines and move them from one site to another. All that leads to creating one virtual hardware platform across the business, which allows data center engineers and admins to operate more efficiently in a disaster recovery scenario or testing environment. If they have to restore applications and data from tape, virtualization allows them to quickly spin up a base virtual machine image with the necessary patches and backup software so that can help speed the recovery from tape backups. Automation is now possible as well, in that the servers are abstracted from their underlying physical resources. Automation is a key piece to creating a repeatable and more accurate recovery procedure in the case of a disaster. Before we dive into covering SRM, it's good to remember what our DR capability was like prior to virtual machine technology. We required a one-to-one mapping of protected servers with DR servers. This was because it was the easiest way to ensure that the restore from tape would have the best chance of succeeding. This is due to the fact that the restore would contain hardware-specific information, and having identical hardware reduced the chance of conflicts there. This one-to-one mapping was expensive to provision and maintain, especially since there was no way to extract value from the mostly idle DR server. The testing happened once a year at best, and in most scenarios, businesses were not able to meet the recovery goals or find issues with the restore process that they could then go back and fix to prevent the next time they ran their DR test. It was hard to meet the recovery point objectives, which was the amount of data loss, or RPO. And they also had difficulties meeting their recovery time objectives, or RTOs, which was the amount of time it took to restore service. And this is because of the complexity and rigidity inherent in physical server infrastructures. Also, since many activities can't fully be automated, complex, thick DR runbooks or manuals were created to guide administrators through the manual steps needed to recover their data center. But today we are fortunate to have VMware to help simplify this process. Much of this is due to the properties inherent to virtual machines. Virtual machines are whole computers. Virtual hardware, OS, application, and data. It's all stored as files that can be copied from server to server. VMs can be booted on any hardware running the VMware ESX server platform. This eliminates the complexity by providing a single virtual hardware platform across disparate servers. It also reduces hardware cost through the consolidation of many virtual servers onto fewer physical servers. And we can roll out old production server hardware to the DR site so that we can enable recovery options and get more value out of that aging hardware. The RTO and RPO can also be lowered very dramatically with VMware, which we'll get to. DR plans can be automated by brave folks comfortable with the risk of developing and maintaining scripts or scripters in-house. So although virtualization with VMware and scripting automation can help simplify and speed your disaster recovery options, it can also be an expensive and complex ordeal to provide the training for. And there's also an additional problem in that trying to retain talented VMware engineers with scripting skills needed to provide this level of recovery, it can be kind of a tall order. So even if you can keep those VMware super ninjas employed, they have other duties and responsibilities to maintain. So what do? It sure would be nice if you could find a company that created a product that could provide a supported, centralized, and automated disaster recovery management product for VMware systems. I think you know where I'm going with this. Well, I think you knew, and it was Site Recovery Manager. VMware Site Recovery Manager is the software product that can build, manage, and execute disaster recovery plans. It can also lower your RTO through an automated recovery plan and process. SRM also provides a reliable recovery through automation and repeated testing. More predictable recovery is also made possible by enabling companies to test their recovery plan any day of the week, securely, safely, and without affecting the production environment. Regular testing can help companies fine-tune their DR plan and discover issues and remediate those issues way in advance of an actual disaster. That, in a nutshell, I think is the most important reason for choosing a product like SRM, and that it allows you to test and test and test and get that disaster recovery plan ironclad and airtight. And overall, SRM centralizes and simplifies your DR management. All right, by now I'm sure you're wanting to dive in and learn what you need to know to install and configure your own SRM installation. Before you begin that though, You'll have to satisfy a few prerequisites before you can do the installation. The first is that each site must include at least one vSphere data center. So this means you'll need ESX servers and vCenter servers installed and configured at each of your at least 2 sites. VMware best practices should be followed for the configuration, and this video assumes that you have a solid understanding of vSphere. If not, TrainSignal offers a training video on vSphere that you should consider completing prior to finishing this course. Secondly, you'll need array-based replication between the 2 sites. SRM does not provide a means for replicating VMs as a feature today, so you'll have to leverage one of the many VMware-supported storage partners and their storage replication software. Thirdly, you'll need sufficient resources at the recovery site to support your recovered VMs. If your protected site, for instance, has, let's say, 10 servers and 100 virtual machines, but your recovery site only has 2 ESX servers and not a whole lot of memory, you're going to have some issues. You're going to have to make some trade-offs and only protect a certain portion of those virtual machines. So make sure you have adequate resources at that recovery site so that you can recover all of your critical virtual machines. And finally, you're going to want to make sure that the protected and recovery sites are connected by a very reliable IP network. This is to facilitate a reliable replication of virtual machines at the storage layer, and also to make sure the SRM servers at both sites are able to communicate properly during the configuration and the ongoing administration of the solution. Okay, now you can see that we're in front of a diagram here of a high-level overview of the SRM architecture. We're going to start at the bottom, work our way up. First off, SRM depends on a replicated VMware VMFS data store foundation. This also could be a replicated NFS data store depending on the shared storage that you've chosen for your solution. And this replicates the virtual machines and templates that live at that data store level. Next up is your ESX servers. The ESX servers obviously are needed to run the virtual machines that will be protected by SRM. You need ESX servers at each site. At the protected site, they're needed obviously to run your production infrastructure. And at the recovery site, so that you have resources available to restore your most critical virtual machines. Each site is managed by its own vCenter server. This should be obvious for why that's the case. This is a disaster recovery product. And if we have only one vCenter server and it's lost in a disaster, SRM is not going to be able to function properly. So we need 2 in each site so that in the case of 100% site loss of the protected site, the recovery site will have everything it needs to not only recover the virtual machines, but to continue to manage them on an ongoing basis. Next, you'll see there is the Site Recovery Manager server software, and this is installed at both sites. There's also a storage replication adapter, which is the software provided to the customer through VMware's download site, but this is actually not VMware's code at all. It's the code created by the storage vendor themselves. They just provide it at VMware's site for easy download. This SRA is actually what communicates to the storage replication. Another item of note is that each the vCenter server and the Site Recovery Manager server have their own database. We'll talk about that a little bit more detail during the installation architecture in the next slide. But there's a database at both sites. Again, for a lot of the similar reason for why there's 2 vCenter servers. In the case of disaster, each server needs its own database to be up and running. And at the very tip top is the user-facing portion of SRM. So the vSphere client, which you should all be comfortable with for talking to vCenter servers and to ESX servers and doing your graphical administration of that environment. There's a piece that you're probably not familiar with, though, that's inside of that, which is the SRM plugin. This is the piece that you download to then configure and manage the SRM server software. So now that we've taken a look at the overview at the high level, let's look at just the pieces that we'll be installing as part of this installation. In this graphic, you will notice that there are just a few components to the SRM installation. the SRM server. VMware recommends a dedicated server for this, but in a small site, SRM can run just fine on the vCenter server instance if need be. Just make sure that the server OS hosting the SRM server is on the compatibility list and has plenty of resources to drive both the vCenter server needs and that of the SRM server. The SRM database depicted here also needs to be set up prior to the installation of SRM. DB2, Oracle, and SQL Server are all on the compatibility list, but please take the time to verify you are on the supported platform before proceeding. You might be in an older version of the database that maybe fell off of support. Conversely, you might be on a cutting edge version of a database, which could also get into issues if it's not supported yet. The next piece of interest after installation of the SRM server on top of the database is to install the SRA, or the Storage Replication Adapter. This is the storage vendor provided software that allows the SRM server to communicate to the storage replication layer and control the storage replication of the protected data stores. Finally, SRM needs to be configured and managed. And just like I mentioned earlier, you'll need the SRM plugin to accomplish that. This is a nice feature and allows you to manage your disaster recovery configuration, testing, and your day-to-day vSphere administration, all from the same pane of glass that you're used to. That's really all there is to the SRM installation architecture. With that, I think we can wrap up this lesson and get ready for the actual installation. Alright, well that about does it for this lesson on virtualization for disaster recovery. But before we go, let's review what we've learned. In this lesson, we learned why virtualization enables a superior disaster recovery. And that basically comes down to the characteristics of hardware independence and encapsulation, which says a virtual machine is basically a whole server that's encapsulated as a set of files that can be moved anywhere to any hardware and booted. We also learned what disaster recovery was like before VMware. It was expensive to maintain matching identical hardware at DR sites, and it was static and inflexible and very difficult to test. We also covered how VMware simplifies DR. That's not only by leveraging the capabilities of virtualization, but also offering a rich interface to allow programmers to script the recovery of virtual machines. We also talked about Site Recovery Manager and how it automates and enhances DR on VMware. SRM replaces all or most of your scripting and automates your recovery plans. It creates a reliable, testable DR plan, and it also centralizes your recovery to make things easier for your business. Finally, we wrapped up by covering the high-level architecture of SRM, and we looked at the installation architecture so you could be familiar with the pieces that we're going to show you later as we do the installation and configuration of this really cool product. Well, that does it for this lesson on virtualization for disaster recovery. Thanks for watching, and I'll see you in the next lesson.